Hello everyone. Today we are on CodeHS going over AP Computer Science A, the 2025 revised edition, and we are on the very first section of the entire course, 1.1.1 Introduction to Algorithms. Let's get going. So computer science is a study of how computers work and how we can use them to solve problems. There's a variety of computer science fields, but we are going to be focusing on the programming side. So programming is not just having an idea, okay? You have to put this idea into simple steps and break those steps down in an ordered fashion and explaining to the computer what you want it to do. This is called an algorithm, okay? Define step-by-step processes to follow when completing a task or solving a problem. So an example that's commonly used in computer science is making a peanut butter and jelly sandwich, okay? Everyone knows how to do that, the steps that it takes to successfully do that. Sequencing is a vocabulary term talking about the order of those steps and having to do those in a specific order in order for the algorithm to work correctly. Okay, if you switch this order around, it wouldn't make any sense and it wouldn't work. Okay, so there's more than one way to create an algorithm. There's more efficient ways to do it, but there are definitely different ways. And so not every way of programming is the same. You can program the same end output in multiple different ways. But the key here is to break the problem into steps, manageable steps that you can organize and order in a way that makes sense so that the output is what you want it to be. Here they have a quick exercise of how to write out an algorithm, and so they have a couple examples of a well-written algorithm of brushing your teeth, getting ready for the day, driving to school or work. Any process that you want to do, you just need to break it down step by step to answer this question. So moving on to 1.1.3 notes, basic Java program structure. So the reason we use Java is one of the most popular languages, primary language for developing Android apps, used to develop large, reliable software systems. Honestly, there's quite a few higher level languages like Python, C++, among others that would work, and you would still learn a lot of the same concepts, but it would just be written in a different way. And so one of the main things that's great about Java is it's an object-oriented programming language, which means you can build your Java program with multiple classes. These classes are basically just Java files where you can specify certain things that you want it to do and group your functions or what you want your program to do in certain categories. So you can think of a class like a container for code that has a particular purpose, like has a name or something specific that you want it to do. So specifically, a class groups together related data and actions. So not only was I talking about the functions, but also the variables or the values that you want those classes to hold on to. So the actions are called methods, and the attributes or data are called variables. And so you may have a student class, and this student class might have things like a name, age, grade level, GPA, and then you might have a teacher class. They could have specific things to the teacher like their employee ID number, how many AP classes they teach, or whatever value you want that teacher class to have. And then a course class would have a name of a course. Is it semester long? Is it year long? Is it an AP level course? Is it fill a certain requirement in order to graduate? Those sorts of things. So we're going to focus on the student class and talk specifically about there. I said student name, student grade level, and then methods that could be in the student class might be changing your pathway. Student is a business pathway, and then they want to change pathways to computer science. Changing grade level or graduating to the next grade level might be a method or action that the student class could do. To start, you will write programs with only one class, which we'll call the main class. So a lot of this will be vocabulary that you'll learn later on, but it's important that you understand at least how to write this. So public class, my first class. So this is how you would write out a main class, or more specifically, so this is how you would write out a class. Okay, public class, my first class. So your class name, it needs to be descriptive, and it's going to use upper camel case, meaning that the first word is uppercase and every additional word will also be uppercase. Allows you to easily read what it is, and the computer only will identify it as one thing, because you don't have spaces. It wouldn't try to identify it as two different things. And then these curly brackets, or curly brace, interchangeable terms there. I will use the term curly brackets, but that signals the start and end of whatever you are defining. And in this case, we're defining a class, and so this would be the start and end of your class. And then inside of your class, if you're creating a main class, you're going to need a main method. So this main method is a special method that is going to be called when the program is run. And so eventually we're going to make multiple classes. One of them will have a main method. And when you run your program, it will be a folder, a Java folder, that will have multiple classes, which are just Java files. But the folder, or the execution of the program, will be executing just the main method, but the main method might call upon other classes. So the main method is like an engine of a car. Without it, the program will not run. A lot of terminology here that we'll go over later on, but public static void main string args is something that you either need to memorize or have down somewhere or consistently look up if you can't remember. It is the way you define your main method. Again, open and close curly braces signal the start and end of your main method. Okay, here are comments. They don't do anything besides give a little bit of instruction or information to someone who's reading the code, but it doesn't actually run anything when we're running the program. It's just more details about what you're trying to convey. So each line of code is a single command for the computer to follow called a statement. These are not statements, those were comments. This would be called a print statement. Now I know it's a lot here. Again, you're going to have some of this vocabulary we'll go over later, but essentially you're accessing this system class and calling upon the output and saying that we want to output a print line or printing text to the console. And so we're just going to start off with printing hello world, which is a very common first lesson, printing to the screen, announcing to the computer hello world, that the computer is able to speak to the world. Okay, and so here are the steps. You want the parentheses around containing what you're going to print, and you later on we'll learn how to add different things onto this besides just text. You might add variables or whole numbers, which are called literals, int literal, of like a number or value. But for now, we're just going to print text. And so with any text or string value is what we'll call it, you would want to enclose those with quotes. So we're going to go to the CodeHS editor. I'm going to skip over the live coding with the IDE because I'll just talk through the IDE here in a moment. But we will go through this quiz. What is the name of the special method that is required for the Java program to run? That would be the main method. Okay, which of the following code statements shows correct indentation? So you want to indent every time you're inside of a set of curly brackets. So this would be an indent and this would be a correct indent. So that will be our answer, but this is incorrect. No indents, too many indents here. You just want to put the curly brackets underneath the P in public, but indent only inside of the curly brackets. So everything inside of here should be one indent over. Everything inside of these curly brackets should be the one more indent over. This is two indents from this set, which is incorrect. And this doesn't indent inside of this set of curly brackets. So first one is correct. Which statement will print the adventure begins? So system with a capital S, they don't mess you up with that, but you need a capital S dot out dot println, even though I say print line because that's what it's short for. It is println, lowercase both. So these two would be one of the correct answers. This one does not have quotes, so we know that this would be our correct answer. All right, now we're to 1.1.6, which would be our first exercise problem. So a couple things here with the first exercise problem. You have a couple different tabs you can go through. Here, the output, you can run it. Test cases, when there's going to be more than one thing it's checking for in future lessons, you will use the test cases to check code, and it will do a few different tests to make sure that you did the problem correctly. We haven't done anything yet, so it says add another print statement about programming. The docs we'll use later on is documentation, so it'll give you some information about how to do some of the things that you've already learned, so very, very useful. And then going back to the assignment, is always nice to be able to look back at what you're actually being asked to do, besides just with the pop-up on the first page. And then your teacher will grade it, and you can look at that and more. You can go back in the history. I have a teacher edition, so I have a solution and some other things that I can do, but those that would be all the tabs that we really need to use. So it wants us to run the program. Were you correct in your prediction? Why or why not? So you wanted to predict what the program would print. Hello world, congratulations on your first Java program. Yes. Remove the quotes around hello world, so that line 5 is just hello world, so that would be an error. It would be looking for the variable hello, and then the space would also throw it off, and then looking for the variable world. If they were actual variables, you would want a plus in between them as well, so that there would be a variety of errors there. Remove the empty line on line 6, so the statement 5 and 6, what happens when you run it? Well, nothing will happen. Java ignores blank lines. It's just for readability purposes, so nothing would happen there. So after you've done all of that, add one more print statement. Programming is fun. So practicing writing out system.out.println doesn't hurt anything, but copy and pasting is fine as well, if that is something that your teacher has left available on CodeHS. So we'll do that. In the future, and more difficult problems, always running the program first is a good idea to see what actually gets output, to make sure it is doing what you want it to do, and then we test it. There we go. We can submit. Great job, your program works. Now we're on to 1.1.7 welcome program. So all of these comments you can ignore. It's just for someone who's writing their code purposes of details or instructions, sometimes in this case to tell you what you need to write. You can erase it or type below it. The same thing will happen. The assignment says my name is Tanner. My favorite hobby is programming, of course. Run it, check the code. Perfect. Running more tests. There we go, running more tests. Testing to make sure everything's great. It is. Submit, move on to the next one. Okay, this ASCII art is a way of just printing multiple lines. It's really difficult to figure out what these are, so I always suggest students to use copy and paste. So this looks like its own line, and I'll show you how all of this works. So I'm going to try to speed through this a bit. We know that we're using system.out.println and then quotes, and then I will use a semicolon here and just pre-finish it. And then I triple click to highlight all of it, and I use Command C, Command V, 1, 2, 3, 4, 5, one more. Okay, and then I do a little bit of copy. You don't really need to copy the extra spaces on the end, but it also helps me make sure that everything is lined up well, because the quotes should be lined up correctly. If I copy this whole thing, this is much faster than adding in your own spaces and trying to figure out where you're missing a space or something like that. So I always suggest students do the copy paste. It does not change your skills in programming, so I don't see why that should be an issue. And there we go. So hopefully that's correct. Yes, it looks like it is. There we go. All right, now we're on to our next set of slides of section 1.1. We're 1.1.9, compilation, execution, and errors. So compiling is a big part of programming. You don't really see the compiling aspect on CodeHS because it both compiles and runs at the same time. And so the compiling turns our written code into computer readable code. And so at some point, eventually it gets to ones and zeros, and then that is able to be run by the computer. So the compiler translates our code into something the computer can read, and then we print hello world. So this CodeHS is an IDE, so Integrated Development Environment, which allows us to write our code and it be translated into something the computer can read and then output for us to see. So a tool that programmers use to develop their programs, and when you hit run, CodeHS Editor first compiles your code and then runs it at the same time. A lot of code editors have a compile button and then a run button separate. It's helpful because there are bugs that are compile time bugs and runtime bugs. So compile time error and a runtime error is what we'll call it. And finding and fixing these errors is called debugging. So we write the code, the syntax looks good. Syntax error would be something that we might be shown prior to running the code, like forgetting a semicolon or not typing something out that makes sense. And then a compile time error would happen when the code is being compiled and it's turned into computer readable code. The computer identifies something that it cannot read. It does not understand. And so compiler checks for code for some errors. Errors found by the compiler need to be fixed before the program can actually run. So syntax error is a mistake in the program where the rules of the programming language are not followed. So we miss a semicolon, miss a curly bracket. There we go. Hey, there's an error. So syntax errors are found sometimes automatically prior to compile time. There's a little underline or something from the editor. And then there are also compile time. Those are considered compile time errors. But when you compile the code, oftentimes they will also could be identified at that point. So basically, before the code is actually run, the computer has identified an error in your code. That is compile time error. Runtime error has two different possible problems. There's logic errors and then true runtime errors. So a logic error is a mistake in the program that causes it to behave incorrectly. So the program compiles, it runs, but it doesn't output what you expect it to output. So to find a logic error, you have to test your program to see if it actually outputs the expected output. So we wanted to print hello world on two separate lines is the expected output here, but it actually only prints on one line. That is a logic error. You have done something that doesn't cause the program to crash, but it is not printing what you expect it to print. So you want to split that up into two separate print line statements so that it does actually print on two separate lines. So then we get to runtime errors. A runtime error is a mistake that is in the program that occurs during the execution of the program. So it expects a letter and you put in a number, so it stops. An exception is a type of runtime error caused by an unexpected issue that the compiler did not catch. So it snuck past the compiler, but it causes an error. The main ones that you'll see are an index out of bounds error, which we'll use with strings. Strings we'll talk about later as have certain locations, and which is string is a set of text. And if you go outside of the text and try to identify a letter, let's say, at position 10, but there's only 8 letters in the word or in the text, you are going outside of the boundaries of the text. And so that would not be caught until the program is run. So that would be an example of a runtime error. Another common example of a runtime error would be dividing by 0. It would cause a number to be infinity. A number can't be infinity and stored on the computer, so that can cause obvious issues there. Okay, debugging quotes. We'll go through this. Okay, 1.1.10 debugging quotes. We have our print line statement. Oh, there's no dot. It should be system.out.println. Quotes, this looks good. System.out.println, quotes. Oh, double quotes at the end. That would be an issue. We want the starting and ending quote. That's it. This does not have a semicolon. System.out.println. It is. That looks good at first glance. We'll see if I miss something here. This, you can see this is not colored correctly. It should be a different shade there. And so we add an M, and then this one also the wrong color there. Should be blue. And we'll see when we check the code. All of that, when I run it, I already know that that's all going to be printed, so I'm just going to go straight into checking the code. And it looks like I fixed the bug on line 1, line 2, oh, line 3, and line 4. Okay. Line 5 looks good. So line 4 and line 5, we're still working on it. And then there's like still a bug, make sure it runs successfully and the output matches the expected output in the exercise. Okay, so it's probably something to do with the expected output if I did that correctly. Okay, this is not in my code. So I need to add a system.out.println under light attracts bugs. Programming is the way. Okay, so I need to make sure that is actually up here. Quote, paste, semicolon, and then I need the name of the programmer, Donald Knuth. Here we go, semicolon. And then Nolan in the brief history. Okay, it's unlikely that you'll be the first. Okay, and then Andrew Hunt. Okay, I think we got it all fixed. We'll check that code again. So, incorrectly typed the errors in the investigation file. Explain the type of error. Okay, and then for the debugging.txt documentation, you want to make sure that you identify each as what type of error they are. So the first 5 were syntax errors. They're errors that cause the program not to run. And then the last one was a logic error, which output something different than what was expected. So we'll go through 1.1.14, section 1 quiz, algorithms, programming, and compilers. So what is an algorithm? A tool used to edit code in an IDE, a set of rules for detecting program errors, a process that defines step-by-step instructions for completing a task, a type of error that occurs during program execution. So an algorithm is a set of instructions, right? A process that defines step-by-step instructions would be our answer there, right? So in programming, what does sequencing determine? So sequence is the order in which you do something, the order in which steps are executed, yes. Okay, which of the following are true about an IDE? An IDE provides tools to write, compile, and run code in one place. Yeah, an IDE is the only place where code can be written. Well, I wouldn't say that. Code can be written in a variety of places, but it can only be executed in an IDE. You could do code in a Google Doc or something. An IDE often includes debugging tools to help identify and fix errors in the code. Yeah, absolutely. So that would be our answer there, and more explanation if you need it. So, which of the following describes a logic error? A mistake detected by compiler before running the program. No, it would be after the program's run. It just doesn't work the way you intend it to. An error that occurs during the execution of the program. No, program doesn't crash on a logic error. A mistake in the algorithm that causes incorrect or unexpected behavior. There's our answer that we're looking for. And then a runtime error typically causes the program to compile successfully but print warnings before the program runs. No, it runs the program, not before it runs. So run successfully with unexpected result. No. So although it runs, a logic error would run successfully with unexpected result. So execute successfully without output. Stop abnormally during the execution of the code. So while it's running, it stops abnormally, divide by 0. It goes out of bounds, out of the boundaries of a string or something of that nature, are a couple examples of that. So what will be the output of the following code segment? So println, CodeHS ID. Okay, so 3 separate lines. This would be an error though, no quotes. Due to syntax error, yes. Okay, CodeHS. No, the space is ignored. Should be inserted between the 2 print statements. Yeah, if you want a space, you need another print line there. All right, so that's it for section 1.1 of AP Computer Science A in CodeHS 2025 Revised Edition.